My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe. Today, we are going to look at research paper titled, Merging Perspectives on Secondary Minerals on Mars, a review of ancient water rock interactions in Gale Crater Inferred from Orbital and In-Situ Observations.
The majority of the Martian crust is of igneous or volcanic origin, although past several decades of Mars exploration have demonstrated the breadth and variety of sedimentary processes on the surface of that planet. Many of these processes are observed at multiple locations across the Martian surface. Past rover missions have focused on assessing the habitability and organic preservation potential of Mars, where sedimentary environments and minerals of non-igneous origin are of great interest.
That's great, Higgs. Phyllosilicates, sulfates, and iron oxides are the most prevalent secondary minerals detected on Mars from orbit and the surface, including in the Mars Science Laboratory Curiosity rover's field site at Gale Crater. This review compares orbital predictions of composition in Gale Crater with higher fidelity in situ measurements by Curiosity. The researchers synthesize how this information contributes to the understanding of water-rock interaction in Gale Crater.
Yes, that is so intriguing, Boson. The Curiosity rover has observed a breadth of secondary mineral phases in Gale Crater that were created throughout the long history of lacustrine activity, burial, diagenesis, and exhumation. Secondary minerals have been emplaced by a series of complex and overlapping aqueous events.
Wow, Higgs, there is so much to explore on the Red Planet. Characterization of the chemistry, mineralogy, crystallinity, and geologic setting of this material allows for fluid models to be developed that represent various stages of the crater's history. This combined orbital and in-situ iterative approach can influence and inform the planetary science community's consideration of future rover exploration.
Advancements in our understanding of Gale Crater provide an important foundation for upcoming in-situ exploration of the Martian surface, and many of the lessons learned at Gale Crater can be transferred to the Jezero crater setting. Jezero crater presents a different environment in several ways. It has a clearer inlet and subsequent delta visible from orbit than Gale Crater, as well as a preserved outlet channel that breaches the eastern rim, providing clues to lake depth.
Wonderful, Higgs. Although still clearly a lacustrine environment, this will have important effects on the hydrological setting compared to Gale Crater. Although sulfates have not been mapped in Jezero crater based on orbital spectra, it is extremely likely they will be found in the lacustrine strata based on our growing understanding of how common they are in aeolian sediments and diagenetic features across Mars.
Wow! That is amazing, Boson. Balancing orbital and in-situ perspectives to fully capture an environment's mineralogy, geochemistry, and paleo-environmental records comprise the critical frontier of Martian surface exploration. Our understanding of Martian surface has grown enormously in the last several decades. Detailed fieldwork via landed missions is now providing great advancements in our understanding of Martian evolution.
That is great observation. To summarize, secondary minerals are a primary focus of Martian exploration as they are indicators of habitability, as well as possible sinks for biosignatures. Determining the precise timing of aqueous processes takes an integrated and iterative orbital and in-situ view, centered on secondary minerals and their geologic context. This will be the next step in determining planetary evolution and habitability.